Alex's Lane part 2. Sweet, let's go. So this is starting off with the visualizer. So the visualizer, I finally have a stupid command pattern for. Amazing, amazing, thank you. I have it going off so that I can process them here. And I also have a wonderful factory that I forgot to pull up, but here it is, amazing. So I decided to pull them each into their own individual command pools because brain wasn't working and I couldn't figure out how to put them in just one. So it works basically the same way. And then go ahead and gives the proper command. So this is going to be making the commands and then recycling them, because recycling is great. Save the planet. Different class. Wow, okay. So it's very simple, except for one part gets a little funky. I have these two variations. One's called like show bsphere and another one's called show bsphere on command. The ones that you actually want to use are going to be these ones, the ones without the command, because the ones with the command are used for the command, and I think I could have made it a little cleaner, but it works. I'm excited. I was so excited when I saw it work. So it was just a naming thing that I guess I maybe could have clarified a little better. So this one actually goes through, makes the commands, submits it into its own wonderful register. So in here I have in my scene I have the ability to submit to Visualizer Manager, which isn't quite like a Visualizer Manager, it's this processor right here. So it just goes ahead and adds the drawing command into a list. So that way it can go through, clear them out, and do its goodness. The visualizer has its basic showing of the bsphere, AABB, OBB. It's able to show the AABB. I call it show single terrain box. This essentially just takes the min, the max of vectors and creates an AABB out of it. It also has it just has the basic bsphere. This I don't really actually remember, so when you're grading, kind of ignore that, because this is where it actually matters, is getting the bsphere and getting the AABB off of that. So when we're in here, then it goes ahead and creates these wonderful, wonderful graphical objects. And for showing the bsphere, it just does wonderful math and it gets everything that it needs and puts it into place along with its color. There's a couple parts in here that I'm not 100% I remember on, but for example with like this, where we're asking to show the collision volume and we're going through the debug view, that's a very step within the collision testing, where I have the ability to say, hey, this dot is this call right here, the getting the correct things and doing the dot debug view. So it is in part with the colliding ability. So just to kind of teensy clarify just a little more, we're actually going to go into the debug view. So then it goes and says, hey, show blah blah blah, show, this is where that show name versus show command, this is what the show name is, the one that's used, and it continues on like that for all the rest of them. So the only one that was, I said, a little different was this showing of the single terrain box. So I just make my scale and my box and I go ahead and base it off of these two vectors so that I can get the appropriate terrain working. And I have these guys right here. In here, my wireframe and my unit box. And because I am curious, this B-sphere thing up here is never actually used. I don't really know why they're in there, but they are being cleaned up, so it's okay. It works. And then moving along into the math tools, probably the other huge piece between math tools, visualizer, and the terrain. They're all kind of their own wacky masterpieces, I'd like to call them. So we have our good old bunches and bunches of intersections. So this intersect, this generic one, is for the continuing of the accepting of the intersection. That one isn't actually true of how it's fleshed out. I thought at the beginning of the quarter we needed to have a general volume and set up with everything, but in the end it turned out that was unnecessary. So we have the intersect between the sphere volumes. It's just a simple distance between your points minus your combined with the radius added, and if it's more than that, then you're not so Gucci, but it is, if the radius plus the other radius is more than the distance, then you're golden. So with the intersection between the sphere volume and the AABB volume, you're just checking if you are inside the box. So excuse me, at first we do checking if the sphere is in the box, because if it's in the box, then, well, we know it's true. It avoids the rest of the clamping and the distance between the points, some of the more expensive tests of the two. So down here we have the sending to the clamp, and then within the sending to the clamp, then we actually do the clamp, which is right below it, right here, to get the correct point in which we need to be at. And coming back up, we also have our basic AABB volumes, where it just checks, am I in between the intervals? If I'm not, then poop. Well, if you are, then sweet. Along with the OBB volumes. Now, this part I managed to get cleaned up a little bit so that my vector list isn't recreating every single time, and I don't have increasing amounts of memory being used up every single time. So that's wonderful. I just passed it in, the vector as a list, and then it goes ahead and mutates the list in there so that I may use it down here. With the max projection, I have its own function for that because I thought maybe I'll need it for something else, maybe not. And then it goes ahead and checks out everything in here. Now, I don't know, for the love of God, why the OBB versus ABB and the OBB versus OBB will not work with scale. I cannot find it. It has bothered me all quarter. I've asked other people. They've said it looks fine. If you can find it, that'd be great. Thank you. Continuing after that little rant, so then we check, oh, is my B-sphere colliding between a unmade AABB? And it's actually set up the exact same way as B-sphere and AABB, where it does that same sphere in the box magic. Your basic, just distance between your points, your interval testing, clamping, spheres in the box, point in the sphere. Wonderful, wonderful function that I don't remember if I actually use. Point in the box, length of vect squared, because, you know, I wanted my own version of these when it literally is done for me already. But at the time, it made sense, along with getting your correct projections. So just as a note, I do use the word deprecated, and I probably am using it wrong for some of these functions. But for example, this one is the one that's currently in use for computing all the axes. This is also checking if the vect is 0. Logic makes a little no sense unless you read the thing that says vect is 0. Because if it's 0, then it's gonna, if it's not 0, it's gonna return false because it's gonna be something crazy. And then continuing, here's my max projection. I labeled everything, so I thought everything was right. It works with the 1-to-1 scaling, otherwise it's kind of funky. And then down here I also make sure that I can be able to compute an AABB from a sphere, which was very handy for that initial where every volume has the B sphere, and then this one happens to be the AABB created out of that one for the big AABB. For these ones down here with the get max, get mins out of vex and floats, that was being used for my terrain, and I had started barycentric, but I never finished, so we're not gonna see that tonight. And that would be about it for my math and visualize tools. That would be the end of part 2. Sweet.